In the previous video, we looked at simultaneous equations, and we can use the solutions to a pair of simultaneous equations to represent the points of intersection of their graphs. So let's look at an example. So let's say we have the following. We want to draw on the same axis the graphs of 2x plus 3y is equal to 8. And we also want to draw 3x minus y is equal to 23. Okay, so what we'd do originally and initially is obviously draw a pair of axes. And I'm not going to do this fully. You could obviously calculate, making tables for each of them. So for instance, if we were going to do 2x plus 3y equals 8, we could draw a little table of results here, and we have the x and we have the y values. And we can say, well, if x is equal to 0, then what does that make? 8. And then we could just keep doing, like plug in what would that be if x is 1, what would y be? And then we get a bunch of coordinates, which we can then use to create our graphs. But you can do that if you want, but I'm just going to show you the general structure of how this sort of thing works. So we have a y and we have our x coordinates, and then we're going to have 2, 4, 6, 8 along the bottom, and we're going to have 1, 2, 3, 4 on the y-axis. And what you'll find is that if you do this sort of format to work out the coordinates of each line, and we're going to have a linear sort of line here because both of them can be expressed in this format, y equals mx plus c. So here if we rearrange this one, this would be y equals 3x minus 23 if we were to rearrange this formula here. So they can be expressed in this, so we're just going to have two lines that hopefully intersect like that. And if you were to do these properly, you're going to get a line that probably looks something a little like this on this one. And that is for 2x plus 3y equals 8. And then for 3x minus y equals 23, you're going to get a line that looks a little bit like that. 3x minus y equals 23. And so if we were to solve this simultaneous equation, and if you don't know how to do that, I will look at my previous video and that will explain how you can solve a simultaneous equation, then you're going to find out that the solutions match the algebraic solution to the simultaneous equation itself. And that would be 7 on the x-axis and negative 2 for the y. So it's like minus 1, minus 1, minus 2. And we can see this is minus 2, and that is 7. And just to show you that that is correct, I will quickly solve the simultaneous equation here on the left-hand side. So if we take the bottom equation here and rearrange to put y by itself on the left-hand side or the right-hand side, we're going to get y equals 3x minus 23. Okay, so that's quite a simple way just to rearrange it to get y by itself. And then we can plug that into our first equation. So that would give us 2x plus 3 times 3x minus 23, which is equal to 8. And we can now expand our brackets to get a full expression here. So that's going to give us 2x plus 3 times 3 is 9 times the x, which is x, minus 23 times 3, which is negative 69, and that equals 8. And so let's collect our like terms. So we're going to put 9x plus 2x is 11x, and then we're going to add 69 to both sides. So that will equal 77. And then we can divide both sides by 11. That's going to give us x equals 7. And there we go. We can see that x equals 7 over here. So that's correct. And that's where they intersect. And then we can plug this into one of our equations. So let's say we put it into the second equation here. We've got 3 times 7 minus whatever y is equals 23. And we can then therefore rearrange that, or we could have just used this equation, but hey ho, it doesn't really matter. But 3 times 7 minus 23 will equal y, and we can plug that into our calculator, and we're going to get y is equal to -2, which is exactly that. So you can see how we can solve simultaneous equations and see that the pair of simultaneous equations, the solutions to a pair of simultaneous equations, will represent the points of intersection on our graph. So that gives us our -2 here and our 7 here.